Hey everyone. So we are doing a quick panel on interoperability solutions, how they have evolved across the time. We have got some really good projects here. I lead Ecosystem at Zetachain. Zetachain is an omni-chain platform which enables cross-chain infra, very similar to other layer 0 or XLR, but we have our smart contracts. We use MPC TSS address to do the cross-chain. But I just want to use this time to interact with these protocols and find out more and just keep it interesting from technical as well as business point of view. So maybe we can start with a quick round of intro for each one, and then we can dive deep in. Start?
Happy to kick it off. I'm Griffin. I'm the founder and CEO of Halliday. My background before crypto is actually embedded operating systems at Stanford, so did a lot of work for RISC-V and ARM chips. If there are any embedded OS people out there, we can chat after this. And then I did zero-knowledge protocol research, sort of academically before starting a protocol. And now sort of where the business has taken us is embedded commerce for modular chains, spending the first dollar on a new block space and sort of packaging that in an all-in-one checkout solution. So you can almost think of like a PayPal-style button, but for automating commerce on a new app chain. Make it easy for your users to bring volume into new block space.
Hey everyone. So I'm Siddharth. I'm the co-founder and CEO of Skate. And at Skate, what we're trying to do is basically build infra through which you can run your apps on all the chains with a single application state. So how we basically put it is like right now, a lot of new L2s and all are rolling up, but all of them would need certain basic Legos. Like everyone would need an AMM, NFT marketplace, lending market. So similar to basically what client-server architecture does in traditional computing, where basically you can open, say, Google on your laptop browser, your Android smartphone, your iPhone or something, but in the browser side or in these different places, they only have a basic piece of code of basically how to take the user's query or how to sort of display the query results and all that. But all the heavy lifting is basically done in one centralized hub server and all that. We're trying to do similar kind of transition for Web3 apps for these Legos that everyone would need, where basically there would be one hub blockchain that will have all the core application logic and application state. And all these different chains will just have a user interaction component, which will be very minimalistic, just for taking user intents and sort of like giving people feel basically that as if they're interacting with a single app on all the chains. So yeah.
Hey everyone, I'm Chris. I'm a research engineer at Across and was involved in designing the original protocol. I also work at HackVC in a part-time capacity, and I'll tell a little bit about Across. So Across views the interoperability problem primarily as a liquidity issue, and that's primarily what we're focusing on in the beginning. We think if you can fix the liquidity fragmentation issue for users, this fixes 90% of the issues for users today. So that's primarily where we're focusing today. And then layering composability on top of this in the form of hooks and other things that we can talk about in a bit.
Awesome. Hi, everyone. I'm Arjun. I'm one of the founders of Everclear. We were formerly known as Connext. Everclear is a protocol. Everclear is the first clearing layer. It's a protocol that negotiates the global ordering and settlement of flows between chains and basically acts as a back-end liquidity mechanism for other bridges. We believe that at a high level, the future of this space, the future of interoperability is intense, and we'll talk a little bit more about what that means and how that relates to Across and a bunch of other people on this panel. And we think that in order for Intense to succeed, you need to be able to provide the best possible liquidity, back-end liquidity for Intense solvers, such that you can scale out solvers to every ecosystem.
Thank you. So I think next as a step, we can just dive deep more into each protocol and how you address interoperability, and if any particular aspects that you're stressing. One is liquidity, but I think we can start with Everclear. Like, how exactly do you, like, what's the architecture to match the solvers, and how do you make it efficient? And just a clear definition on like what aspects of interoperability you're focusing on.
Yeah, for sure. So we've maybe a little bit of history here is helpful because I think it ties into a lot of the work that's been happening with Intense lately. Like Connext, as we were formerly known as, first started working with interoperability back in 2021, and we used this model at the time not really called Intents, but now you would call it Intents, where we would immediately front the capital to the user on the target chain, and then but like some actor, which we called routers at the time, but now you would call solvers. These solvers would go and front capital to a user on a target chain instantly, and with really effectively zero trust. And so you could make this, you could scale this model out to any number of ecosystems very effectively. It could work with any kinds of chains, and it was basically an iteration on like a lot of the old like atomic swap infrastructure that existed from the Bitcoin days. What we found at the time was like the model is fantastic, right? You can deliver incredible experiences, right? This across is a fantastic example of this, where like you can make transactions happen across chains in seconds, and ideally we can get to like web scale milliseconds. These transactions can be bundled into calls that happen across chains. You can interact with apps in a way where you don't really know that the app is living on another chain in the first place. But what we always kept running into was the same problem, which is our solvers, who at the time were like staking service providers, basically professional node operators, were struggling to actually keep uptime. And when we dug into why, we realized that for them, these solvers were not market makers. They were not used to figuring out how to manage inventory. And when they were going and filling a transaction, so delivering, say for example, you're going from Arbitrum to Optimism, so delivering USDC on Optimism and then getting USDC on Arbitrum, what they had to do to get back to Optimism was rebalance. Rebalancing means getting your funds back to kind of where they belong, using other mechanisms, right? Using other bridges, using centralized exchanges, using market makers, using canonical bridges. And as it turns out, rebalancing is like the limiting reagent to be able to scale out these systems. What Everclear does is like double click on that specific problem, where we realized, especially as we saw this market expanding, as we saw across Uniswap X, DeBridge, Squid, everybody else start working on and pushing forward the intense like approach, we realized that everyone was going to run into the same issue, which is how do you actually like rebalance all of these solvers in a way that's cost effective for them. This is effectively what Everclear does. Everclear allows solvers to basically find coincidences of wants with each other. It's almost like you can kind of think of it as like a very slow cow swap, where instead of finding cows in the process of making trades, you're actually a solver that's finding cows in the process of rebalancing. And so it happens over like a 3-hour period instead of like a 2-minute period. And what we found when we started looking at the data was like, in practice, about 80% of the total volume between chains actually nets off. So in practice, solvers need to rebalance 5x than they currently do, 5x less than they currently do.
Yeah, so thanks for laying out the foundation for why intents are good. I'll give a bit of a context on like how we view intents and how we view this solving the cross-chain bridging problem, and then maybe it's useful to double click on specifically how we view this rebalancing problem, because I think you're 100% right, this is a hard problem for any kind of filler network. So yeah, Cross is an intent-driven bridge where effectively users signal the intent to move from one chain to another chain. Maybe that output action involves some other kind of action involving like deposits or something like that, but functionally we have an intention to do something in another domain, and we have a marketplace of relayers who fulfill those intents. Where Cross is unique is in how we actually net settle those intents fulfillments and how we prove the output of those. So we do batch settlement for all of the relays that have fulfilled intents across all the networks. So you can kind of think about this as like performing a MapReduce operation over all the deposits that users have done and the fulfillment of those deposits. So a user moves from Arbitrum to Optimism, a relay picks it up and fills it on the target chain, and a relay does this over a period of time, and then we batch repay the relay in one transaction. And that's part of why Across is so fast, is we have this marketplace where people are competing on both price and cost, and we have batch repayments for the relays. I think some of the interesting components here that differentiate Across's intents from other designs, and this also helps with the liquidity issue, we enable the relayers to receive repayments on any chain, so they can actually use the Across system to manage their inventory implicitly. So maybe a relayer fills something moving from Arbitrum to Optimism, they don't have to go and fetch that deposit from the source chain. Maybe they want more inventory on Polygon, so they then actually choose to receive the repayment for that action on another chain. So they can then actually dynamically adjust their inventory and move it around depending on the repayment. The other thing that's unique about Across is how quickly we can actually do these repayments, and this time continues to go down. So at the moment, Across uses the UMA optimistic oracle to actually do these batch verifications of repayments. And this enables us to have quite high speed repayments, but we have some designs potentially that can bring these times way, way down. But yeah, functionally, the quicker you can repay relayers and the more preference you give them on where they receive those repayments, the better they can manage their inventory. And yeah, ultimately that's up to the relayer to manage their inventory, which is definitely a little bit out of scope for us. But yeah, that's the high level idea.
I think just one more clarifying question here. Like when you say repayments, like could you just define how the repayments work just for setting the context?
Sure. So if you consider a number of actions that users are doing between different chains and relays are filling those actions on different target chains, a repayment is the summation of all of those actions that they have filled. So maybe there's, 10 users moving from Arbitrum to Optimism, 5 moving in different directions. The key components of across in terms of speed is that we can bundle all of those repayments into one transaction. So it's the sum of all of the actions that they have fulfilled in one transfer.
Essentially, it's just a settlement of the payments, right, at the end of the cycle.
Exactly.
Okay.
That like nets off the
and that
relayers
is across
actions.
the chains and across all the different token modules.
Yeah, exactly. So instead of repaying a relayer for every single transfer that they fulfilled, we can send one payment per currency per relayer.
Okay. Yeah, makes sense. Sid.
So I think so far we have extensively touched on the liquidity fragmentation, how basically intents some way solve that. And in general, I think the key question always emerges in the sense of we have this problem because on the interoperability side of things, it's not fast enough to have at the application level. So basically, interop just takes the form of bridging, whereas we try to find some other underwriter for sort of having quick settlement so that the UX is still usable. So from my perspective, I was basically on the other end of it. Basically, I used to previously work at a trading desk where we had built this RFQ quoting engine for hash flow for we'll be settling like a good percentage of like volume there. And like when Skate previously was called Range Protocol, and at that time our focus was just started from this vision only that what if I can do active management on these Uniswap V3 like DEXs, but when I want to rebalance, I can pounce on these different private market makers, fillers to sort of do the liquidity aggregation for me. They can do all the heavy lifting of like taking a little bit volume from different places, but just giving me a non-custodial on-chain code for that. That's what we were doing. But at some point, as these new L2s emerged, like what was happening with us is that we realized that you also have to solve this information asymmetry, because on most of these L2s, the most actively traded pair would be say ETH USDC. But right now, each chain has its own version of Uniswap V3 fork, and each of them has its own liquidity curve for ETH USDC. So at that point, like fillers and all are great, but when markets are one directional, what sometimes can happen is basically all the fillers will run out of the inventory at the same time. So basically then you can't have the market shut down. So the backend of that basically would be AMMs, where in moments of high volatility or the fatter tail cases, that's where the AMM basically are reliable. But the current model is super inefficient, that if I have to actively trade ETH USDC pair on multiple chains, I need to have like at least 10 million liquidity on each of these roll-up, which does not make any sense. So that's where we sort of got about this vision that liquidity is just one problem with it, and like the whole idea for Skate sort of emerged from that. But more than that, like what we thought of is that right now, if I have my application's metadata on one particular L2 or rollup, I'm just restricted to that ecosystem. What if I want to expand to more and more ecosystems and say, now Blast is giving a big airdrop, I want users from there and get the network effects from there. So that's where we sort of started building. And then the first pilot that we're trying to sort of do now is that build this like cross-chain AMM, but it's like a concentrated liquidity AMM where if say, I add 10 million liquidity for ETH USDC on Arbitrum because that's where most of the major trading volume is. But now if a new gaming L2 rollup comes in, I can just bootstrap 100K liquidity for that. But in that 100K liquidity, again, I'm updating the same application state. So there's a single liquidity bitmap for Arbitrum and new gaming L2. So now when you're trying to do a swap on this new L2, you don't get a price as if you're trading on 100K liquidity, but rather as if you're trading against a 10.1 million pool, because both of them share the same QA. So from our perspective, the idea is like more from the application level perspective, definitely with fillers and having some other underwriters, you can just like make the UX even better.
But essentially you're also solving the liquidation thing.
Yeah, the liquidity fragmentation, yeah, definitely. Like that's the most clear problem that you see with the emergence of all these L2s. But a few other use cases, like say L2con is a very good example. So as people keep registering their iris data and like so L2con keeps updating the Merkle tree root on Ethereum, But what if I want to enable like a proof of personhood on base? Then I have to replicate all that data there. What if I want to do it on like Blast? I have to replicate all that data here. So from those kind of scenarios, we're targeting how basically we can have this hub and spoke kind of model where I can enable these apps on all the chains. And from users interaction side, they just feel as if they are interacting with a single app.
Makes sense.
Yeah, happy to talk about this. I think one perspective we had and how we've treated or approached this differently than others is we're not technically an interoperability provider. We work with many interop solutions, and what I like to say to people is intent-based bridges, liquidity, fast bridging, all of these amazing technologies make it possible to offer interoperability. What we do is we make it usable to the end consumer and the application developer to then plug into all of these downstream services that offer different functionality. And the reason that something like this is necessary, building sort of an automation layer and a sort of consumer developer facing embedded commerce layer, in the sense that in the real world you have Visa, MasterCard, is there's a lot of heterogeneity, right? There's integration work across every single blockchain. There's many different app chains being launched. There's many different bridges. There's many different canonical bridges. There's OP versus Arbitrum versus EK Sync versus AVAX. A lot of this starts to add up, right? You have to do 12 months of integration work to connect to commerce that exists elsewhere. And you can assume by default that most of the volume and most of the economic activity within blockchain is not happening on your platform. So our entire business is designed around making it as easy as possible for volume elsewhere to come to you. And that's a one-click embedded checkout solution that automates things with sort of an asynchronous, committed programming model that abstracts away much of this complexity. So a lot of these folks and InterOp are actually business partners of ours, and we're sort of a complement when we talk about automating and making it easy to interact with many different systems.
So I think we can start with you. Like, while solving this problem with the e-commerce angle, like what sort of advances you're seeing in the interoperability space, and what are still one of, I would say, the prominent problems in the space? And where you think you are filling in the space. I think you already answered a part of it, but just want to understand a bit further how you approach it.
Yeah, I mean, we're certainly adjacent to InterOp. I think one of the things that I'm excited about that enables our business is actually the work that Across and Everclear are doing, which is very helpful, which is making it easier for people to run solvers, right? A lot of times the limitation for a fast bridge is liquidity. And it's challenging to manage liquidity. There's also a lot of sort of adverse selection and cold start problems, which is a big market maker going to take price risk on a long tail asset? No, they're not. And the business model of these market makers, right, is sort of an option. You take out a loan on an option. It's hard to get those guys to take a long tail token, which is why you see a lot of asynchronous message passing is still the dominant form of bridging in the long tail, right? So it's like these sort of permission staked multi-sigs that move messages across. Making it easier to have fast bridging would be great. You just need to find the counterparties that are willing to actually do this at scale. It's also sort of a question of, will small solvers be able to compete with the large hedge funds and financial institutions? So I think the clearing and making it very easy to move balances across is a very, very helpful primitive that enables a whole slew of businesses on top, such as ours, where we would love it if there was a universal liquidity layer that we could plug into seamlessly, right? That's a part of the stack that our customers want that enables our business.
Cool. So would you say you are building on top of the providers like Across?
Absolutely.
So you're adding on the building block that they are building upon?
Yeah, I mean, we build on top of many blockchain services and protocols.
Okay.
And, like Across does bridging, and they do it very well. And we do embedded commerce and have on-ramping, off-ramping, a bunch of different services and automations. But that primitive is a very helpful product and requires a lot of focus. Like, how do you actually manage liquidity? We're not a liquidity. I'm not a hedge fund. My background is computer systems, right? And I think, if you look at previous payment markets, there's usually a pretty clean separation between the technology providers and the network systems and the people who are underwriting risk, right? Visa and the banks are very different. PayPal is very different than the underlying payment system. Stripe is very different than Visa. That's sort of how I see things playing out. Like, if anybody's going to do liquidity well, they should be focusing on it because that's a hard business.
Yeah. Cool. Sid?
Yeah, so I think in terms of the changes that in general we're seeing, I think right now the whole market is becoming a bit more UX savvy. Like, even from the primary market side, the way a lot of VCs are structuring their funds, like the mandate is to be more consumer facing and all that. And whenever we consider that in terms of how it would replicate in terms of like InterOp, it's mostly InterOp is always like a trade-off between trust assumptions and latency. So somehow basically you want to offer better latency by offering a little fewer trust assumptions and all that. So there's a lot of play between that. I think Everclear is like a great project. I sort of see that as rails for everything cross-chain in the future. But I'm also seeing a lot of other types of InterOp come up, which is trying to make composability across different tech stacks, like between EVM and like say Solana VM. Now, like I feel like there's an emergence of these like EVM L2s, which are not EVM stacks. Sorry, Ethereum L2s, which are not EVM stacks, like Move VM, Solana VM, like Eclipse and all that. So that offers like new ways of you to customize the InterOp solution. A lot of I see developments are happening on that side. That's something we are super excited about.
Cool.
I just wanted to clarify, are you asking the change in the space or the specific parts of InterOp?
So I think how the space has evolved and how you are addressing that change, and probably what are the still big bottlenecks in the interoperability.
Okay, cool. Yeah, so the space has changed obviously by having many, many more chains, many more user intentions on what they want to do, many more targets that people want to bridge to, and every chain that you integrate with requires, I mean, as was said, right, new integration, new code to be written, more adapters. And I think our approach has been to focus primarily on where the users are and what the users want, and not to try and go to all the chains immediately. And so far this has been a good strategy, so we can focus like limited resources as effectively as possible. And I would say like the biggest things that we're seeing now is around like how do we gradually add composability. I think systems that are like overly generalized from the get-go tend to not win outright. Like you need to be solving one specific problem in the beginning and like targeting that specific use case. So in our case, it's like, how do we move small size most of the time as quickly and cheaply as possible, or up to medium size? Like very large bridging actions is not really like optimal for like intent-driven models that have market fillers a lot of the time due to a lot of the portfolio and rebalancing complexity there. So that would be definitely a thing. And I would say in terms of like limitations at this point, I think there's a few dimensions that I see this problem on. One of them is not having like fast finality guarantees on a lot of chains puts a lot of unbounded risk potentially on relayers. So having like pre-confirmations and potentially like single slot finality and these kinds of technologies actually be offered to relayers where they can have higher guarantees that they will get repayment is a big thing. And you know, this is obviously, if you look at like what it across actually, why it is faster than a lot of other designs, it's because the relayers are taking on that risk, right? And they need to then price that into the rates that they offer. So I think technologies that enable higher confirmation guarantee and just basically de-risk that for the relayer will definitely enable costs to continue to be driven down. And then obviously, I think with bridging, as we kind of see across the panel here, there's a lot of different layers to the stack, right? So other components like enabling relayers to maybe use other technologies to rebalance their inventory, while we can focus like specifically on the user's demand is also very interesting. As well as like composability on both the incoming and outcoming side of a bridging action, right? Like we're talking primarily here about moving assets from one chain to another, but normally you don't just want to take your ETH from mainnet and then put it on Optimism and leave it there, right? When you get there, you want to do something with that ETH. So technologies that can enable us to have more expressive composability on the destination side, I would say is also like a bit of a gap in the design space at this point.
Yeah, that's an awesome summary, and a lot of that is kind of echoed from our side as well, where like we've had really similar experiences. Our design was probably like, I think Across and previously Connext were probably the most similar in terms of design, where we were like the two first kind of intent-based models looking at these markets to figure out, okay, how can we make solving extremely easy, and how can we expand it to like all of these different use cases. Since you've covered all of that super well, I'm going to try to focus my answer to this on like more how the broader interop space has evolved, because I think that's also like a really important piece of context. So in 2021, when a lot of this kicked off, unfortunately, there was just like a lot of immaturity in the space. And I mean this in like a technical standpoint, like a research standpoint. There was just not enough context to be to understand what kinds of user problems exist. And so there were a lot of projects that just like went and raised insane amounts of money to be like, we are going to be the cross-chain protocol. Now, obviously, in retrospect, this is ludicrous, right? Like, this is going to be a $1 trillion space. This is the future of the internet. Like, this is how, like, cross-chain is how the internet will work in the future. And so, you know, it seems kind of insane to think that this would be like a problem, a set of problems that is solved by a single organization. And we're starting to see that now, where like over time, different protocols have started specializing into different parts of the stack. So you kind of, you know, Griffin, I think you mentioned like Visa as an analogy, and I think the banking system is a really, really good way to understand like how these things are getting kind of split up. So for instance, at the base layer of all of these interactions, you have like messaging protocols like Layer 0, Hyperlane, Polymer, IBC, et cetera, that are basically just ways to kind of transport information between chains and that don't really necessarily give any guarantees around security. And this is almost like quite similar to like the role that like other settlement mechanisms in the banking system would play, or like TCP would play in the internet, right? Where it's like TCP is not making any guarantees around like the security of the data. That's like higher up in the stack, but it is getting data from point A to point B. And then kind of we've sort of like started to now build on top of this, where you can build in like, you know, security using things like EigenLayer, using things like, you know, zero knowledge proofs, using things like large scale validator sets, et cetera. Or UMA's optimistic oracle, for instance. And then on top of that, now you have this like new paradigm, which is intense, which is almost like the layer 2 of interoperability. It's kind of how we think about it, where like, you know, interop you can do, and we have been able to do in a way that's very, very secure, but expensive and slow through canonical bridges and things like that. And so how do we make it fast and cheap? Well, we have this mechanism that batches up many, many, many user transactions into one single like consolidated netted flow of funds between chains. And so yeah, I think like what we're sort of discovering overall as an ecosystem is that like it is like it's counterintuitively like there's a lot of different problems here, and it's actually more effective. You're more likely to succeed if you focus on one very specific problem than if you try to solve all of them. And so I think like I'm sure everybody up here has kind of experienced this, where it's like, yeah, like this is just such a beast of a problem space that you actually really benefit from prioritizing something.
Just to like touch upon the intent base, like how do you manage as a protocol to access ecosystems which are not really EVM? So let's say a Ton, for general, like it's a rising ecosystem with traction. There's a Solana, which is not EVM. Let's say there's a Bitcoin liquidity, which is out there. Like, how do you think about accessing these assets? And are you already doing it? And like, where do you think are the constraints there? And is there an opportunity there? That's a big question.
Yeah, that's a really good question. So like, there's really 3 pieces that are kind of needed for an intent protocol to function. And by the way, like this, like as a sort of binary question, yes, you can build intent systems on any system, right? Like Bitcoin atomic swaps have been around since 2010, and like that has been how the dominant paradigm for Bitcoin interoperability for a very long time. And even Bitcoin like cross-chain atomic swaps follow the same kind of rule set, which is you need some mechanism for settlement, and like typically in the past this was like using a signature or using like an HTLC, or in the modern day this is like using some sort of like message transport protocol or a canonical bridge. Then you need the actual intent protocol, so some mechanism to just like lock over a resource, in this case funds. So like in an atomic swap, this is like locking your funds on one chain. But it can actually be really any kind of lock on any kind of resource, which is potentially interesting and something that a lot of people are starting to explore now. And then the third thing you need is the LP, the solver, the person who's going to be the counterparty, right? So who is on the other side of that transaction. And so to expand to any new chain, we've spent a lot of time thinking about this, because this is a big part of like how we're trying to think about, you know, what problem does Everclear solve, and how does it actually like help intent protocols get everywhere? How do we get to the point where this works on every chain and not just a subset of chains? For us, like we have been trying to figure out, okay, how can we make sure that those first 2 pieces are in place, where it's like, you know, solvers, it's very easy for solvers to go to a new ecosystem. It's very easy for a settlement mechanism to be available in a new ecosystem, such that an intent protocol can then just go and figure out how to do like the actual implementation piece, right? That how do you actually like implement the intent, like implement locking or whatever on Bitcoin.
Anyone wants to take this? How you're solving this?
I can add a little bit. So we're only on EVM at the moment, and we only on chains that have canonical message passing infrastructure because we don't want to rely on any external message system, primarily because in a system like Across we have LPs who sort of facilitate a part of this liquidity problem that we've been talking about. They act as kind of like a lubricant in the system so that if there's an imbalance in the ecosystem, we can use LP funds. And as soon as we introduce a chain that doesn't have a canonical bridge, we expose LPs to additional risk. That's not to say, obviously, we haven't thought about these problems, right? So I think there's ways that you can partition risk and expose different LPs to different kinds of risk if they're okay with that, and continue to try and move more and more of the risk onto the relayer and try and let them be the primary person taking on this kind of risk, and they can price it in. So an example could be you could have a version of Across, just as an idea, that doesn't actually have LPs, and it's just an intent fulfillment layer, and then how the LPs or how the relayer moves their funds back and forth, you leave that completely up to the relayer, right? Like that's a variant of Across where you still use like our batch settlement, batch repayments, like the verification logic, but we just don't use the LP capital, and you can still get a lot of the benefits there and you move it on to the relayer. The other thing I'll say is what's interesting about intents when we think about a multi-domain problem is that intents, if framed correctly, don't really care about the source or destination chain, right? Because it's all about how we parameterize things, right? Like an intent could say something like, I have this many input assets, I want at minimum this many output assets. Those input and output assets could be of different type, and then it's a cross-chain swap. And I'm on this chain and I want to go to this other chain, right? Like how you interpret the input and output chains is kind of unimportant. So moving to like Solana or whatever, in theory, is kind of simplified in some ways through having this like higher level ability to specify your objective function through an intent. So it kind of acts as this like level of abstraction in some ways.
Yeah. So running into, let's say, as a protocols, you start supporting assets which are not natively or there are no solvers or layers supporting it. So I think one of the core problems that I've seen or that we see from Zetachain is also the UX thing. With the intent, I think intent itself is summarized as the UX for the user end, like to make it as simple as possible for the users to just have a order book and just say that this is what they want. For this price, and someone will solve for it. Like how are you approaching UX? Just want to take your perspective on your experience on UX and how you're optimizing that.
Last question here. Okay, so I think there's maybe 3 components to this. When we talk about UX, there are users that are going directly to like the cross UI, and they have a very specific objective function, right? I'm on chain A and I want to go to chain B. That's probably the least interesting user group. We then have users that go to aggregators. Maybe they're more sophisticated and they want to move from chain A to chain B and compare prices without having to do it manually. Often Across is the cheapest and fastest solution in a lot of those bridging cases. And then the third user group, when we talk about UX, that I think is the most interesting, and this is part of the Cross Plus product offering, is where we want to offer applications who are on maybe one chain or a set of chains, but not all chains, the ability to pull users to their target chain. And this is kind of the Cross take on how we deal with interoperability. So an example could be you're only on Polygon and you want, and like in order for users to interact with your app, they have to first get to Polygon, right? So normally the kind of UX flow here is pretty nasty. You arrive at the app, you see, oh, it's only on Polygon. I don't have any assets on Polygon. Now I need to go find a bridge. I bridge across to Polygon. I reload the page. I spam F5. Okay, my money is there. Now I go use the thing. So our solution to this is how do we create a plugin effectively for an application where a user can, in one click, deposit on the source chain wherever they are, and then assets are moved on their behalf to the target chain, and then some sort of hook is executed on the end. So that could be depositing into the protocol or executing an action. Like obviously we need to be careful about what that hook is. Like it being a Uniswap swap, for example, is probably not a great idea. That's probably a great way to get completely wrecked on the target chain. But if it's something that doesn't generate MEV or have like ordering preference, which is I think the majority of cross-chain action, that works pretty well. And then I guess like a fourth category that we're starting to explore a little bit more is where you have a hook on the input side, right? So that might involve like a swap on the beginning or something like that. But yeah, a lot of that can also be abstracted away if you're talking cross-chain swaps by the solver network itself, right? You can do cross-chain swaps where the solver is taking on all of that risk. But yeah, those would be the 3 main categories in terms of how I think about UX on a cross.
Yeah, thank you. That was a really good answer.
Yeah, just to piggyback on that. So I think this model that Across is doing, the cross process, it really dovetails nicely into a lot of the work that's happening around chain abstraction in the space. Chain abstraction, if you haven't heard about it, is like a narrative, a vision, an outcome that the space is working towards, where users should really never have to care about what chain they're on. And a big piece of this is kind of addressing this like really problematic design pattern that we have all somehow like just adopted, where like protocols are going and copy pasting their application onto like every single chain and then fragmenting their liquidity, right? Like it doesn't really make sense. Like if Aave wants to provide the best possible lending like depth and pricing, then they shouldn't have their protocol deployed on 11 chains. They should be deployed on one chain and make it accessible from any chain. This is the like shift that's kind of starting to happen. Yeah, it's kind of insane, honestly, when you think about it, that we did this. It's starting to happen. Like protocols are starting to head towards building app chains.
This is exactly what we are doing at Zetachain. Like you deploy one smart contract on our chain, and the chains that we are supporting gets access to all the assets, and you can basically run any applications through one deployment on our chain through the connector
right.
chain.
So one other thing that we're seeing is that most major applications are heading towards building their own app chains, and like this sort of makes sense, right? They want sovereignty. They don't want to be bottlenecked by like other things that are on the same chain. Even in a like L2 driven environment, like Arbitrum kicks off like an incentive program, and then all of a sudden like gas fees go through the roof, like uptime is degraded, and then if you're building like, say you're building like Reddit or something on Arbitrum, what are you going to do? Like that's obviously an unacceptable outcome. And so I think most projects are starting to head towards this model where they're like, yeah, we want our own like containerized environment, but we want it to be accessible from everywhere. And this is how we get there, right? Like getting to this point where like you can go and fill in like intent solvers can go and fill intents to go and deposit into Aave chain or into like Unichain or whatever is how we get to the point where like it's completely abstracted. And so yeah, I think like we've sort of been doing this for a while as well. Actually, I remember Hart and I talked about this a couple of years ago, and because we were just like, hey, like this seems like an obvious answer, right? Why is nobody else doing this? Why is this space not heading in this direction? And it's awesome to see that now, like 2 years later, we are at the point where like things like Across Plus make sense. Things like the chain abstraction toolkit that we launched last year, which does something very similar, also really like make a lot of sense for application developers.
And like, sorry, small thing I'll add on that. I think like there's a lot of technology coming out now around like trying to abstract away the wallet from the user and trying to create like these universal wallets, and like I think these are really interesting ideas, but the reality of a lot of them is like it's very opinionated often in how you need to interact with it. So incremental steps that fix like immediate problems is kind of like where we're focusing right now, exactly to this point, right? Rather than trying to fix like, let's have a universal wallet that has gas everywhere, like let's solve like the immediate pain points and then iteratively build on that rather than trying to create like a generic solution that catches everything.
Yeah, makes sense. I think let's do one closing round of thoughts. Like, what is your advice for developers who are building InterOp solutions? Like, what they should focus on? Yeah, I think we can start with you.
I think if we're talking about new solutions to InterOp, I think there's an exciting space of zero-knowledge-based light client bridges. So I think fundamentally InterOp is a message passing problem. It's a state synchronization problem. And as the cost of zero knowledge goes down, that becomes a very compelling way to synchronize state, because we all share the same state root. So if you can communicate really quickly using message passing, it's a pretty effective system. And you sort of see some of this starting to be done with ZK Sync, right? They have a native bridge that is actually just a zero-knowledge light client bridge. And it works because everything on the stack is ZK, so every hyperchain can talk to every other hyperchain. I think the current form of InterOp, it's pretty mature. Like, I think these companies are big, people have built a lot, there's market makers, it's very sophisticated. I think the next frontier of interoperability is thinking about some of the other mechanisms that can either enhance or provide fallback mechanisms. And zero-knowledge computation, you see projects like Succinct, Nexus, right, who are building generalized ZK VMs. And what these are doing is they're bringing the cost of ZK compute down to the cost of classical compute on these chains. And once that happens, that opens up a whole plethora of applications, because one of the hardest problems has always been light client bridging. But if you solve like RISC-V on a ZK VM, you've done light client bridging. And that's a very exciting world.
Thank you. Quite insightful.
Yeah, I think I forgot what the name of the panel was, but I think it was something with InterOp. But right now, like anyone would have seen, like the key buzzword right now is intent. So that's just basically a placeholder. Like going forward, like there's a lot of focus on the UX side, And intent is basically like a placeholder for underwriting a better UX with InterOp, because we are going into a mode where there will be so many chains, so you need to have a better UX. I think from my perspective, one thing that I'm super excited and I think a lot of development will happen on that side is that this basically opens up a model of basically asynchronous interactions, in the sense of you don't need to get settled at the end of transactions. You need to, like, there could be a callback for you to settle, get settled later. But so far, all the conversations, like initial use case is more on anything with the asset level. But like with all these ZK co-processors and a lot, with blockchain, you have to have certain trust assumptions, and that sort of limits in terms of what all you can do. But if I want to say take certain part of computation off chain, have only certain parts of my tech stack have these trust assumptions, only they should be on blockchain, then I can do so much more off chain. I think a lot of these AI, ZK, AI blockchain, I don't know how it would be, but you can't run those kind of models on chain in any capacity. Like even for inference, you can't run it on chain. So you have to take it off chain. So a lot of these Web3 applications would come up where they would be asynchronous. They'll have an off chain component. So a lot of the InterOp developments also would happen on that side, and that's something like that would be a completely new design paradigm for the applications. And personally, I feel like all these current synchronous apps where it's like a bit more generalized model, like Uniswap XY equal to K is a very generalized curve. You can do so much more. So basically the reason that RFQ picked up, or basically intent-based solvers and all picked up, is because they can do so much more. They can basically hedge on Binance, Coinbase, OKX at the same time and replicate a code, versus you're competing with that with an XY equal to K curve. So with that asynchronity, you can do so much more. So I think right now we only see it in terms of liquidity side of things, but at the application level, you're going to see a new design paradigm. So that's something I'm super excited about.
Okay, I'll speed run this a little bit. So advice would be focusing on specific things. Don't try and be too generalized, which I think is related to what you just said now. I think identifying like specific user problems that exist today, right? The landscape shifts very quickly in layer 2, but there are problems today that can be solved, so be very specific. And try and solve like actual frictions for those users, right? Like if speed is the more important thing than cost, then maybe it's okay to not be the cheapest if you're the fastest, right? Yeah, I'll give an example. Like when Circles Bridge started coming out, and like we were looking at this, like for a moment we were like, okay, we're dead, right? This is like the end game is that all these native issuers are going to just like Tether's going to have their own, Circle has it now, like we're dead. But the reality is that users actually often care more about speed than anything else. Like, and we had identified a specific problem that the user cared about. And if we're comparing like, okay, I move 1,000 USDC and it costs me 1 cent versus 2 cents, but the one takes 15 minutes and the other takes 2 seconds, well, most users are going to choose the faster one. So focus on a specific thing, and then design your mechanism to solve that one problem, right? So that would be my main advice, is to be precise in what you're trying to solve.
Yeah, that's a really great answer. I think there's a few problems in InterOp right now that are just like open greenfield spaces where there's just there's an opportunity to build like wildly profitable businesses. One is how you're going to do security between these different chains. So like building like ZK like clients on SP1, like to Sync's SP1 right now would be an incredibly profitable business, because like every single message transport protocol is going to need them, and they're going to pay tons and tons of money. Like layer 0, Hyperlane, everyone is going to need them. That is just a totally unanswered question right now, and nobody's doing it, and there's so much room for competition. Another wildly profitable business right now is just running a solver for intent protocols, right? Like there's so much demand for order flow coming from these intent protocols, and there's not enough solvers to fill all of it. Last quarter, solvers on the Connect bridge were earning 100% APR on ETH, which is fucking insane, right? Like that's wild. And that was stable yield, no risk. You're just holding ETH, and you're not even doing anything. There was no inventory management or anything like that. And then lastly, I think that like we're only just starting to scratch the surface of the types of order flow that can exist. So like trading is like one obviously big behemoth where we're like, okay, of course this is the big thing that everybody wants to talk about and wants to do. But as solving gets easier, as like things like Everclear help make it so that solvers can go and work with any ecosystem, things like that, as we start to get into these like longer tail app chains, as we start to get into more interesting use cases, there's going to be big and really interesting opportunities to build more intent protocols. There are a lot of intent protocols out there today. There's a reason why just about like every bridge is pivoting into being an intent protocol, and like there is, and I still don't know if there's actually enough. Like I think that there's actually so many different kinds of specializations that you can do at the intent layer to try to capture different ways, different preferences that users have. So yeah, that's kind of my blanket advice. Is like those 3 problem areas are just really, really greenfield right now.
Yeah, Cool, perfect. I think we are at the time, but thank you so much. I think that it was an honor to moderate this thing.